Precipitation reactions are ones in which soluble ionic compounds form an insoluble ionic compound. Okay, so let's look at an example. This is a net ionic equation for a precipitation reaction. You have aqueous silver ions, you have aqueous chromate ions, and they form a precipitate, which is a solid silver chromate. So this is the precipitate, and it falls out of solution because it's no longer soluble. Okay, so the way that you tell if something's going to be a precipitate or not is by using some solubility guidelines. So I'm going to give you a few solubility guidelines so you can tell if something is going to form a precipitate or not. And these are not perfect rules, but they tell you when something is probably soluble. Okay, so if something has an ion in group 1A, like sodium, potassium, lithium, then it's probably soluble. And if it contains ammonium cation, then it's probably soluble. So those are the cations that are usually soluble. And for the anions, we have a longer list. The halides, like fluoride, chloride, bromide, iodide, except when they are paired with lead 2+, mercury dimer 2+, or silver, as in the example above. Silver, oh, it wasn't with a halide, but it was silver. Okay, so except for that example. All right, nitrates are generally soluble. Perchlorates are generally soluble. Acetates are, and sulfates. Now there are exceptions that apply to all these, just like above, and they do include lead 2+ and mercury 2+, but they also include barium 2+, or plus, 2+. So those are the guidelines, so now we can use those to predict when something is going to be a precipitate. So let's try practicing this. So the general way to approach this is look at the reactants, and you already know that copper nitrate is soluble because it's got an aqueous. We already know that ammonium carbonate is soluble because it has an aqueous. That means it's soluble. So now we just look at how we would pair the cation from this substance with the anion from this substance, which would be copper carbonate. And you know that this is a 2+ ion because there's 2 nitrates, so there would be 1 to 1. And the other possible product would be this cation, ammonium, with this anion. So we pair those up in the appropriate ratio. And then we look at the solubility guidelines and decide if they would be soluble or not. Now, nitrates and ammonium compounds are generally soluble, so this one is going to be soluble. But carbonates are generally not soluble. Okay, we don't have carbonates on the list for soluble anions, so we're going to designate this as a precipitate. All right, let's look at the next one. We have these 2 soluble compounds. The possible cross products, meaning a cation from one with the anion from the other, are lithium nitrate and sodium hydroxide. Now we saw that nitrates are soluble, so this compound, no matter what the nitrate's paired with, would be soluble, although it's also lithium is also one that is soluble. Group 1A elements are soluble, so even though it's with a hydroxide, this one would be soluble. So there is no precipitate in this reaction. Okay, there was a precipitate up here. There's no precipitate in the second one. And the third one, the possible cross products. Magnesium nitrate. And remember, you need to have 2 nitrates for every magnesium. and lead sulfate. So let's look at them. The nitrates are soluble, so this will be aqueous. And sulfates are soluble, but one of their exceptions is lead. So this would be a precipitate. So there's a precipitate, and you had precipitate in the first one. The middle one had no precipitates.